project. I would like to ask each of the panelists to introduce themselves and tell us what role they have on the project. I would like to start with Dr. Mahto. All right, you can.
So my name is Rakesh Mahto, and I'm an assistant professor for computer science program. And my role in this part to power the sensor network, which gonna do the fire detection. So it's gonna be basically powered by solar energy. So that's what like my part come into play in this project.
Thank you so much, Dr. Mahto. Now I would like to introduce Dr. Mahapatra.
Hello, everyone. I'm an assistant professor in the computer engineering department. My work on the project is to design the actual sensor nodes that are going to help us detect the wildfire accordingly. I'll highlight more on the design as we get into the depths of our work.
Hello, everyone. I'm John Fowler. I'm an associate professor of computer engineering. And my role in this is to develop the mobile app and to integrate the mobile app with the sensors.
Dr. Huang, can you please unmute yourself and introduce?
Hi, this is Dr. Jidong Huang from electrical engineering. My specialty is in robotics, and thank you.
Perfect. Thank you for the introduction.
Thank you so much for introducing yourselves. So to begin with, please tell us a little bit about this project and where this idea came from.
As people who live in Southern California and all of us who live on the West Coast, wildfires are something that are sadly becoming a very big reality for all of us. Every year we have so many wildfires that cause so much damage to life, property, and the California government crosses its budget every single year trying to do something about the wildfires. So this was during a particularly bad wildfire in 2019. I remember just driving around and wondering, what is the solution for this? What is already being done? And I remember reading the newspapers and seeing how the firefighters were constantly stressing themselves out by trying to fight the wildfires for 18 hours and putting themselves at risk. So that's where the idea began. I went online, I did some research, I talked to people. I found out that there are some methods that are already in place by California. For example, they have the Alert Wildfire network of cameras, which is supposed to take images and analyze them if there's a fire or not. The major limitation of that was, first of all, there's a lot of computational power and you have a lot of cameras and the reach of such cameras are very limited. And also if you have something like during fall, you have fall colors or there's a cloud that's glowing with sunset colors, they're also misdiagnosed as fires. So there were all these errors. Then we have satellite systems, but satellites make passes not too frequently. They pass over the same area after hours. So that's not that efficient either, because within an hour, your fire could have engulfed a whole town. So we thought about what we could do to solve this problem ground up. And turns out that most fires, if we are somehow able to detect them at the moment when they are caused, there might still be enough time for someone to intervene and douse out that fire before it becomes so big that it's a losing fight for the firefighters. And that is the basic problem that we are trying to address. So that is where I started. But then as we started talking to more people, you might have read this all over the news. Most 90% of the fires are caused by humans. It's because people get careless. Someone is having a gender reveal party and they set off a fire. So this was at the suggestion of the fire chief of Chino Hills. He said that we need to have a component which educates the public about how to be better at public safety education, what you should do or not do, and be more careful when it's fire season. And that's where our application with the mobile app comes in. So this is an overview of the project. I'll ask everyone else to pitch in.
You want to go ahead first, Rakesh?
Um,
Okay. All right. So my part in the project, as I mentioned, was the mobile app. So and it's more than just an app and the idea. What I want to do is create something that can interface with the sensors, use the sensor data, and then in combination with some machine learning, try to predict, depending on the sensor information, the likelihood of a fire. And it also could be used to communicate any information to the end user about potential fires and also instructions on what to do in case of a fire. So that's my contribution to the project.
Um, my part in this project is basically, as I mentioned earlier, was to power those sensor network. So like we can say that, okay, so we can, Ankita when came to me with this project, so we thought that, okay, we're gonna have solar cells powering those panels, but like those solar panels installed in the forest area gonna be facing a lot of challenges. Let's say there is a cloudy weather. So because of that, the performance of the solar cells gonna degrade, or maybe there's a shading because of the neighboring trees and herbs. Because of that also the performance of solar cells gonna degrade, or maybe it got hit or it get damaged because of some animal or because of high wind that day. So so in that case, that sensor network, even though they are functioning perfectly, because the power is not going to be there, not going to be reliable, those sensors going to be of no use. So for that, like I am working with my student to create a smart sensor so that they can operate even in adverse condition and provide power to the sensor so that they can operate at maximum potential.
And Dr. Jidong, would you like to elaborate on the solar hub or the sensors?
My part of the project is to help create a solid communication network so that data can be transmitted from each node, like those weather data can be transmitted from each node to the center so that the data can be used by the machine learning algorithm to try to detect if there's a fire. And I'm also helping to distribute the GPS receivers at the nodes so that we can track the location of each node to basically predict where the fire happens.
I see. Thank you.
God, I'm so sorry. Panelists, if I can have you pull the microphones a little bit closer to you. That way our audience on the Zoom is having a slight hard time hearing and understanding some of the what's coming through. So if you just keep them closer to you. Sorry for the interruption. Thank you.
So you have all worked with students on this project. So tell me a little bit about the impact that it has had on students being a part of this.
Well, I guess, should I go first? Okay. All right, so I did work with one student. A lot of computer engineers, they don't usually do mobile applications. They deal a lot with hardware, a lot with, they deal with computers, but like smaller computers. So I recruited one student to work with me, a computer engineering master's student, kind of showed her the technology, how to develop an app, how to develop a back end for an app. And she actually told me recently that she's decided to kind of go that path in her career. So I think in that way, I made an impact on a student.
Right now, I've worked with a total of 5 students on this project. 4 of them were undergrads, 1 is a graduate student. 2 of them, one of them is from the Santiago Community College, and he came in with through Project Trace, and he has expressed so much interest that he's still working on the project, and he has other interests, but then now his interests all lie in working with microcontrollers and embedded systems design. So I have students from computer science who are working on this, and right now, so through this project, one student got selected as WellSAM scholar. Then it creates more opportunities for the students because They have had papers accepted in conferences and like the Southern California Conferences for Undergraduate Research, the NCOR, which is National Conference for Undergraduate Research. So it's a good opportunity for them to talk to other researchers, see what other research is happening and create their own network. And a couple of those students are even considering going out and applying for graduate school as well, because they realize that, as John said, that they do like the research. So those are in some ways in which this project has had an impact on students.
So for me, like there are two students from undergrad student from CSUF Fullerton working on this project. And there was one student through Project Race worked with me during the summer semester. So so it was a different kind of learning experience from them, because there is no courses related to how to model solar cells at CSUF Fullerton. So like through working on this project, they basically know basically how to model a solar cells. And not only they are learning that, they are also learning that, okay, how we can use machine learning to make solar cells perform better, so they are learning that, and both students work on this project. That resulted in multiple publications in conferences. And I have one student like who is working on multiple journal papers, which we're gonna be submitting hopefully later in this month. So student has, and some of the students, they presented their work at a prestigious conference and they got really wonderful feedback from the audience. So I'm really happy the kind of exposure my student got through this project.
And Dr. Huang, did you have any experiences with students working on the project?
Oh, yes. I have been helping Ankita with advising some of the students on how to choose proper radios to set up the communication link, because the system has to be deployed in like parks where there's no Wi-Fi, even no cellular signals many times. So we have to look into those license-free radio, and students have the chance to compare different modulation techniques to see how reliable the radio link will be. And they also did the field test. They set up the hardware. They actually write the program to interface with the radio. And this is something, and I believe those students are from computer engineering major who don't really have expertise in RF radio frequency communication. So this will be an experience for them to get exposure to something that might be useful in their future professional career. So I think students does benefit from this.
We actually have a great question going on with collaboration. Can you tell us who you also collaborated with on this project, CAL FIRE, or any city officials that you might have talked with or got information with and partnered on?
Yes, we do have a very strong network of community collaborators with us on this project who advise us, and like we are researchers, we work in the lab, so there are a lot of practical aspects that we might miss, like what public outreach, for example, might be more effective, or like, as I said, the fire chief, he suggested that we should also be looking at just educating the public about fire safety, for example, which we plan on integrating with that app. So we do have council member Cynthia Moran. She's from Chino Hills. We have the fire chief of Brea, Fullerton, and Realtio and Chino Hills on this project as well. We have been in talks with the Chino Hills State Park, and the Arboretum as well. So once we are in the prototype development phase, we can test our prototypes on field, and then we move on to the state park, and then something like even the Carbon Canyon Regional Park. We also have support from it's a neighborhood association called CAL FIRE. You might have heard of it. So they are a group of volunteers who just talk about how to protect your house against wildfires. So they will ultimately, when we are in a deployment stage, we see them to take a more prominent role and advise us on what they would see on the app. So these are some of the partners that we are working with. We are also trying to reach out to San Bernardino parks. because San Bernardino is at extreme fire risk year round. So we are also planning to see if we might be able to test some of our prototypes out there.
And I appreciate that you took on the role of mentoring students throughout this project. As a computer science student, I know that there is a lot of imposter syndrome that goes into students in ECS because of how difficult the subjects may be. But working on projects with them, it does instill a level of confidence that allows students to rise up to the next level. So not only are they learning from you, they are also boosting their confidence by working with you. So again, we appreciate you taking them under their wing and getting that feedback and giving that feedback as well to them. And like you mentioned with Cynthia Moran, along with 46 other alumni, are part of the Titan Alumni Talks podcast. If you want to go ahead and listen to it, and Bill Prepara is here as well. It's on YouTube, Spotify, Apple Podcasts, and wherever else you get your podcasts. So I just had to do a little plug there. But continuing on with the panel, now I'm wondering, what is a future goal? Is this something that can extend further than just wildfire research? How about other natural disasters like earthquakes, tornadoes, or tsunamis?
I can start. And so I think with earthquakes, it's almost impossible to control them. So it's like you might have a little bit of pre-event saying that, okay, there might be a big earthquake, that's all the best they can do. There's nothing really to curb it. Same goes for tsunami, like we had the Tonga volcano going off and the whole West Coast was on alert. But with fire, we can take an action and prevent that disaster from happening. So there's that one thing. The question is good, but I admit that I haven't thought beyond wildfire, and it might be something that
Can I
we
add
should look
something?
at. Yes, please.
So we're using certain sensors, temperature, pressure, and so on, to detect conditions that are conducive for wildfire. But if you kind of think of it as just a sensor network, it could probably be applied anywhere you can use sensor networks. Traffic. I don't think earthquake is a practical one, but other examples of that could be applied to that, I think.
I see. That's interesting to note that it can be expanded probably in the future. So now we're going to go on to talk about the Titan community. So
Actually, Ahad, we did have a question that kind of goes along with what we were talking about right now. And it was just with the research that we've gathered so far and hope to gather, what do we see as like the long-term plan for this research, including the app? I know that there's a chance that we can use the sensors in different ways, but for your research, this project in particular, what's the long goal? What's your milestone that you hope that, where you see like we did it kind of thing, but where do you see this going in that sense? And in 5 years from now, and with the app and the sensors and all of that?
We do plan on testing at least have a prototype that we can test in one of the parks in the next 2 years. And a lot of things need to happen after then. Like ideally, we would want to be in a situation where we have a network of these nodes implanted throughout the carbon canyon or even a larger area, so that we have a stream of data and we are able to analyze it and see how efficient these are. So those are the goals that we have for now.
I think when the question was asked about tying into other disasters, I think you lost something. If you have an earthquake, you have a potential for open gas line, you have a potential for drought power line. You need to tie in simultaneously for an event for earthquake, tsunami, electric storms, because all of those could result in a fire. So you left too much on the table there. You need to think about integrating this into a system approach that is not just focused on wildfire, it's the impact of the various types of disasters and how they will build upon or cause other impacts. You need to add that to your overall thought.
That's a good point. Yeah.
So actually, like I just want to add to it, like what you mentioned. So like when Ankita came to me about this project, so I thought it's a really good idea. So last year only, like I submitted a research proposal on this topic only, like what in that proposal, like it basically talk about like connecting Internet of Things connected drones. It's basically completely powered by solar cells. So what that's gonna be helping is basically it's gonna be basically a kind of communication link between the, let's say the firefighter is somewhere in the forest. So it's like a kind of missing communication link, because like when disaster happens, so you want to make sure the communication networks are basically operating perfectly sound. So for that, like uh, we are working on that, creating those kinds of drone which can basically work at that kind of communication hub by having this Internet of Things connectivity.
I am going to put that again. My background, by the way, is system architecture, first, second, third, fourth generation of open patents in there. What I'm trying to say is that you're looking at just a sub capability. You got to look at the overarching system here, not just be back maybe talk about somebody else's drones or somebody else's comm systems. That's just a communication level. You got to look at the impact of, if this happens, how will that ripple? How will that change your algorithm? If you suddenly have this weather condition you think is this, but because of an earthquake, that has changed. Or because an oncoming electrical storm tied in with the change in environment here, tied in with something here, you need to have your algorithms talking together with the other systems, because if you have this information and they don't know it, and they don't know that if that happens, it's going to impact them, you're going to look really bad later, because it's the old classic, I didn't know about it, why didn't you tell me about it? So really start rethinking your interfacing between all of the entities, and don't just focus exactly on wildfire. You look at the impact on every other entity in here and look at how you integrate it, and you have to work with them also now to develop your interfaces between them. I'm just trying to ask you to this expand with you a bit.
Yeah, it's a great point.
Great.
So now we're going to ask you a question about the Titan community and how they can help. So why is it important? Why do you think that it's important for the Titan community to get involved, not just with this project, but around CSUF in general as well? But first start with this project.
I can just start off with why the Titan community can get involved with this project, because as I said, there's a big gap in public safety. And right now there's a lot of focus in generating public safety or safety knowledge around wildfires from K-12 levels or even younger. So the focus is that if we could somehow educate them and say they will be the one in turn who will be injecting knowledge into the society, saying that these are the best safety practices. And for that, to achieve that level of cohesive networking, we would need the whole community to be a part of it. Just as researchers or with our students, it's impossible for us to reach out to so many people. So that's where you come in. Would the panel like to expand?
I mean, I have kind of a selfish reason why I think they should get involved with this project. I mean, they can help us test it. I mean, the more people we have involved inside the project, especially when we have a prototype, they could find bugs, find problems, maybe even come up with ideas that we didn't think of, kind of crowdsource information. You have anything to add?
I'd like to touch on that as well. As a CS student, a lot of the programming and stuff that we do, it is just trial and error. And I can only imagine in a project as big as this, it's not really possible for a couple of faculty members and students working alongside to try and get all of those kinks worked out, especially in something as dire and necessary as this. I know from working on my project at home, it can definitely be a help if I had someone trying it out or just testing things constantly, just to give that helping hand. So for sure, having extra people trying it out and testing out the app is something that is.
And then just also, like, as a computer person, sometimes we think, oh, this is perfect the way we made it. And then people start using it and they're like, I don't know how to use this. So it's good to have that feedback.
And then Dr. Huang, did you have anything to add to that?
I think the Titan committee definitely can help us like expand the collaborations. Like, for example, looking for potential test sites to test the system and help us find what type of data will be helpful for not only for detection like wildfire, maybe other possible applications, like someone mentioned earlier, other disaster prevention or early detection. So that's some of the things I can think of.
Thank you. And to end it off, we're wondering if anyone else in the audience has any other questions that they would like to ask the panel regarding this idea project or anything else in general.
We actually do have some questions that did come in. We have some in our live audience as well as our virtual audience. And one of them that came through on our virtual side that we'll get asked first is what are the goals of the collection of the data? So when you have all the data, what is the goals? Is it just going to be to study? Is it going to put into the action of it? Is it just to kind of collect all that data? And the question is kind of broad, but they just really wanted to know what that data is going to be looking like and how we're going to use it, today.
I see. I can focus on that data section for the nodes. So the nodes will have a series of sensors which will all work together to find out if there's a fire or not. But the nodes are just, the sensors are just going to give you the temperature reading or give you the humidity reading and so on. So all of these need to be transmitted back to a central hub, which would be, or the app as we mentioned, like which would be doing the processing. Like, for example, if you see that the temperature stays in 70s and then suddenly spikes up to 78, and simultaneously your particulates and humid also spiked up and the humidity drops, that's an indication of a fire. So there's also data processing that is intended to go on at the same time. So that's how we plan on dealing with the data. And of course, once we know that there's a fire event, the mobile app can alert the firefighters and the citizens saying that there's a fire at this exact location. And of course, we know exactly at which GPS location the fire might be. So that information will be being back. And then the firefighters can take some preemptive action and focus their efforts on that area specifically. That makes sense.
I have a question from the audience.
Oh, yeah, you folks are doing a good job with the macro. Well, find the fire when it starts. I'm looking for a resource that I could borrow for a little while. Someone that knows things about sprinkler systems, pumps, those kinds of things. I have access to a plant-based fire retardant that I'm trying to figure out how I can get on a structure. I know how to get it on a structure. So when the fire comes through, most of the time you have time before an evacuation, right? Okay. So it might take 5 or 10 minutes to get the house phone. Once the danger is passed, you can spray my fire retardant off with water. It's environmentally friendly, non-toxic, and will not harm any of the color, any of the roofing material, anything like that. But I'm having a hard time finding somebody that has the vision that I do. Because I can't imagine coming back to a concrete slab and a chimney. I'm really trying to save houses, memories, all that kind of stuff. Anybody got an intern laying around with nothing to do?
Definitely think that's the goal of the whole panel is to try to find so that people don't have to come back to a slab and a chimney. I agree on that one.
Yeah.
We'll try to find something for you, sir.
Well, I have the perfect plug for that. It's something called Titan Pro Network. And what it is, it's our very own site that is very similar to LinkedIn. And what it does is it allows you to connect with other Titans who are alum, students, faculty, and staff. And just by signing up, you get connected to this broad network, and you can filter it by majors, by year graduated, and all of this and interest as well. So it's a very easy way to sign up and see other people who are interested in something similar. And by doing so, who knows, you can start a small community just like that. So everyone who is here and watching on the Zoom as well, sign up at Rebecca, what's the link? The Fullerton, alumni.fullerton.edu, and it'll be there. Or you can just Google Titan Pro Network and it will show up as well. And this is a big recommendation for students as well, since you can connect with faculty and staff and just figure out what's going on and how do you start your next big project.
I love that information. One last thing, it kind of added insult to injury. You come back, all you have is a chimney and a slab. Insurance now in California is having a hard time writing policies. Oh, you want to build your house again? To my for navigate? Yeah, I don't think so. So not only do they lose their house, they can't rebuild without insurance. Nobody's gonna, nobody's gonna help you with the cost. So that would be my other thing, once I get this system for looks good, I'll take it to every insurance company in wherever I find them.
Just remember who was here when you heard it first, right? We do have one more question from the audience.
Amen, sister.
So you talked about like most fires are human caused. I was wondering, and sorry if you touched on this already, but this kind of goes along with what this gentleman was saying. Is there any part of the project that you think is going to focus on public outreach and education, like how to create defensible space and evacuation plans?
Yes, that's all the mobile application. I think one of the aspects that we were thinking is the mobile app. It has two components to it. One would be where the firefighters are told that there's a fire over here and you need to intervene. And the second would be for the residents, and they would be given evacuation paths. Because right now, if you see the evacuation paths, most of them are just printed out and stuck on poles or trees. And for someone in distress under wildfire is not going to run around looking for directions. So we do have plans for that as well.
And Mr. Adam Aaron, if you'd like to unmute yourself and ask your question, we'd love to have you.
Awesome, I appreciate that. It's much easier to ask these questions. Can you hear me okay?
Yes, we hear you perfectly.
Yeah, so Fullerton alumni currently work for SoCal Edison, actually work directly in this space. So I'm curious about the sensors that you want to put up. Are these weather stations or are these like fire sensors with like AQI sensors in them? I want more detail on that.
What type of sensors?
Oh, if I heard you right, you wanted to know what kind of sensors we are thinking of at this point. Just the regular, they're not too, they're just off the shelf. Temperature, humidity, particulate pressure. Those are and wind. Maybe ultimately we haven't still found out a good, reliable sensor for that. But those four are going to be the main ones for us.
And thank you. And has this panel looked at any existing sensors that are currently out there?
Sorry?
The existing sensors? We're going to be using off-the-shelf sensors, so they're already existing.
Okay, and maybe this could be a different conversation to have, but Edison has about 1,400 weather stations deployed across high fire areas on our distribution poles. And we use that a lot during our public safety power shutoff events. We're turning off the power to prevent fires because it's telling us the conditions, right? And then we also have a HD camera network of 167 cameras locations across our territory, and it's picking up smoke detection, right? And we're working with UCSD and various universities to do machine learning to see, like, because that's where we spot fires is when those plumes start to go. And that's what the firefighters are reacting to. So I'm just real curious on the sensor side and like placement and where you're going to put them. How's it going to integrate into the existing systems that are currently being used?
I see. I'm glad you asked that question. Yes, we do have the camera network, as you said, we also have Purple Air, which has, the Purple Air is all open to the public. There are many sensors, but the major disadvantage of the Purple Air is that it needs Wi-Fi. And as you said, we do have weather stations that give you the status, but weather stations are placed many miles apart. So the idea for us, or the motivation that we have for us, is have our sensor nodes in more remote locations that are not monitored that well.
Yeah.
And also they are going to be low cost, they are going to be low power, and unlike weather stations, they wouldn't need a lot of maintenance. All they do is that they're very hardy points that collect the data from somewhere out there and they relay the information back to you. And then there's a central station that tells you whether there's a fire or not. And this is a much better installation method than having weather stations everywhere.
Okay, and just from my experience with the weather station program, your big challenge is going to be communications and then the placement of that sensor and who owns that right away. Are you going to put it in federal land? Are you going to put it on a pole? You're going to test it? Because these are what the utilities and like the firefighters are going to ask. When you have a sensor, they say, okay, great, where are we going to put it, right? And that's a big problem that we have. And I heard a comment about radios earlier. Remember, you have to skip the radio bands up into those areas. So we've seen satellite work pretty well. It's very expensive, but it allows us to get into those remote areas. And that's what I had for questions. I'll go and stop.
I see. We do plan on working with the existing infrastructure that we have. Like we have weather stations. SCE also has their own weather monitoring stations. So we might even want to piggyback on their existing infrastructure, at least for the main node, so we can send our data back. But when we are talking about very remote locations, what we were thinking of, like this is going to be a small unit with all the sensors, all your solar panel in there. And just at the start, some person would go in and install it maybe on a tree or some sort of a small tower, for example. Not a tower, but just an installed rod or something like that. We are intentionally keeping the sensors very, very simple so that there are less maintenance and installation costs.
Thank you so much. And we have a few more virtual questions, and I also have one in the chat box. And the one that is being asked right now is, have you worked with any other universities such as Cal Poly, since they have a wildfire resilient community, or any other universities that are part of this project with you or you spoke to?
Not yet. We did reach out. We explored the research, but their focus, although wildfire, is on another aspects of wildfire. Like some of them are working on, I think, mobilization after a wildfire, and some are talking about how to make the reintegration into the society or make their life smoother after the wildfire. We do have a team at Cal State who are, I think Rakesh can focus more on the CubeSats. So they are developing their own small satellites to monitor wildfire. So ultimately down the line, we'll also be combining our approaches on them.
Thank you. Would Mr. Nasser like to unmute himself to ask the question?
Hi, my name is Dr. Nasser. So the question, and I apologize if you have already answered that question. So in my experience, because we have dealt with some fires in northern area, and usually these fires, they start from the hilly terrain and then eventually goes towards the populated areas. I understand, like, people who will be using these phones, they must be apps installed, may be able to get that message. But the hilly terrains, most of the places, they do not have that internet connectivity. So how would you tackle that issue?
So I think the app, so are you saying that there's a lack of internet connectivity in the remote areas? Is that what you're saying? I think it's going to be processed on a central hub. And then that central hub would transmit it. That central hub would have to be placed in somewhere where there is some internet connectivity. And the central hub is going to connect with the sensors via RF. So the connection between the central hub and the sensors is through a radio frequency connection, not relying on internet.
So don't you think then that would be a very expensive equipment to transmit that signals from the areas where actually this fire starts and it gets to the populated area? So, I mean, I'm thinking of a Larson community near Reno where I worked. It's a small town surrounded, it's like a valley, and most of the time the fire started in the surrounding hilly areas, and eventually, it blocks all the roads, and by the time the residents come to know it's already blocked, it's already involved thousands of acres of land over there. So that's why I asked this question. How would you get that signal quickly and using this app without using any expensive equipment?
I think I might
That I
have,
don't know.
sorry, misunderstood your question. Is your question more on how the sensors are going to communicate wirelessly and tell some central station that there's a fire, or how is that information going to be relayed to the users through the app? And is your
Relate
question
to
more
the
on-
user of app. Yes, that's what my question. So how it will be relayed to the users who are not living that far. However, the fire starts from those areas, eventually gets to the residents.
I see.
I'm not sure if that's the scope of this project as well.
I see your concern. I think, and John, please correct me if I'm wrong. If there's right now, we have the emergency alert systems that don't really work on internet connections, but if you have some sort of connectivity, they are still going to send the alerts. So we can ultimately work into that system too. Yes.
Okay, let's give you a good example. Silverwater Fire. I have friends who live up there. There is no internet connection. There is no radio connection. They use a shortwave beam to beam, house to house grid to provide their warning system there. What he's talking about is very important. Your app won't work in that environment. Your app, if it's going to depend upon the internet, well, the first thing that happened with the internet is they lost the wires on the lines. They lost internet in the entire area. So you're going to have to change your mindset on how you're going to deal with a world that's not internet-based, not app-based. If you don't get yourself out of that, you're not going to say Silverwater Canyon. You're not going to say the Malibu area where you've got the ravines. And those are where the fires start. Once they build up momentum, then it goes out. So I'm trying to be politely saying, stop looking at what you know and think about what you're going to do if it doesn't exist, okay? Because Silverwater was an example, and you talk to anybody up there that happened, and it's Edison, the rest are still trying to rebuild up there. Fox went down, all the internet went down, and the people were trapped.
These are all really good points. I know that we're in the beginning phases of the project itself, so thank you so much for the feedback on that. And we also have one more question from our audience, Mr. Gonzalez, if you'd like to unmute yourself.
Hello, I'm a recent graduate of Casa Fullerton and a current master's student at North Dakota State University studying emergency management. And I was wondering, I guess, two questions. First off, with your warning system, are you hoping to piggyback off of the reverse 911 system in the event that there is no internet connection? And then also with your map for evacuations, will you plan, or are you planning on communicating with local emergency management or emergency coordinators to see what current maps they have?
Yes, we plan on ultimately doing that, integrating all the emergency services so they can unite their efforts and work seamlessly.
Are there any last questions for our audience? for our audience. I apologize for our panelists.
I just had a quick question. So I understand that this is a broad project and it's not something that maybe a student could just think of and start. But let's say a student has a smaller scale project that just came to mind. What is your advice on getting started that you've seen from like other students and that you worked on the past?
Like finding a mentor? Is that what you mean? or-
Maybe like finding a mentor is the solution, but like just getting started on an idea that they had.
So generally, like what I do, so the first thing I generally ask the student to do some kind of literature survey, like to see like what has been already done, and so that they get a basic idea, like they can do basic research on that, and then build on it. And if they have any question with which I can assist them, or maybe I can point them to some other professors who are working exactly that area, then I can ask them to work with them. So that's generally I do follow this approach.
Yeah, I'm the undergraduate advisor for computer engineering, and that's exactly what I usually tell them. I ask them, think of a class that you've taken that you really enjoyed, and approach the professor, ask them if they have any projects, and that's a good starting point.
Are there any additional questions for our panelists this evening? What I would like to do is just ask each of our panelists to kind of give us a final thought for the project and what your favorite part is right now, or what you hope to favorite part to come, just to kind of close out the evening and just let us know. So if you'd like to start, please.
So my favorite part was like, to be honest, like I was completely ignorant about this issue, and I'm really grateful to Ankita to introducing me about the fire issue faced by Southern California. And I'm because of like the reading I have done in this area, the different possibilities which we can do to prevent the forest fire like came in. Thanks to Ankita for introducing me to this topic. So I'm so grateful to her for that.
The part that excites me about the project is just talking to more and more people, like with areas of expertise that are not that are different from my own. Like the panel that we have right now, everyone has their own niche area, and it's always nice and exciting to see how to rack our brains and see how we can combine our expertise and find a solution to such a problem that's around us, but that we can maybe solve. And it is a good cause. And it does help. I felt like through this project, I was thinking in more broader, I was getting more open-minded and talking to like the community and finding out what they needed and seeing if we had the resources to do that. So I like that aspect. And of course, the research is also, it's always nice to do research with students.
For me, it's being somebody that does mostly computers. It's nice to be able to use that background to help people, whether it's with fire or any other topic. I like this topic in particular because it can help people and potentially save lives.
Same here. Like I feel excited about the project because it has the potential to help people, and it's one of those issues that it's a real challenge for many different parties involved. And here, the conversations with different partners on how to make the project be able to fulfill its intended goals. That is something that I'm really excited about, and interacting with the community partners and looking into the different potentials and trying to refine the system and help students learn by taking part into the project participation. So that's the exciting part of that.
Thank you so much. And if there's no other final questions for our panelists, I would like to thank everyone so much for joining us this evening for such a wonderful discussion on an amazing campaign. If you'd like to learn more about any of the three Big Ideas campaigns from Cal State Fullerton, please visit fullerton.edu/big ideas. Tonight's recording will be available later on, and we will send the link to those that are registered with us. Should you have any questions that come to mind, please feel free to email them to alumnievents@fullerton.edu, and we'll make sure to get all questions to the panelists for answering. Thank you so much again for joining us. We wish everyone a wonderful evening and a safe one. Thank you.